And welcome to an example of finding concavity intervals. So in the previous video, we did one case of finding the intervals where we were concave up or concave down. Here we're going to do another example. So in this case, we are looking to determine where g of x equals negative x to the fourth plus 12x cubed minus 48x squared plus 12x plus 24 is concave up and concave down. So again, the very first thing we need to do is we need to find that second derivative. So we need to find g double prime. So again, g of x is negative x to the fourth plus 12x cubed minus 48x squared plus 12x plus 24. So we have g prime of x would be equal to negative 4x cubed power rule plus 36x squared minus 96x plus 12x, plus 12, not 12x. Right. We just did the power rule on all of these. Now we'll have the second derivative. The second derivative of g, we have negative 12x squared plus 72x minus 96. Next thing we need to do is find where this second derivative is equal to 0 or undefined. So we're going to find where g double prime of x equals 0 or undefined. Once again, in this case, the second derivative is never undefined. Again, we're working with a polynomial. Where we're set equal to 0, we are looking at negative 12x squared plus 72x minus 96 is equal to 0. We can factor a negative 12 out of this, and we have x squared minus 6x plus 8 left hand side, all equal to 0. That factors further. We'll have an x minus 2 times an x minus 4. So we have negative 12 times x minus 2 times x minus 4 equals 0. And therefore, either x minus 2 equals 0 or x minus 4 equals 0. And we get x is equal to 2 or 4. From here, I'm now going to just draw one number line instead of drawing a number line for each step, and we'll just kind of pile it all on top of each other. So we are going to draw the number line. So he had 2 points of interest for x, namely at 2 and at 4. At those places, the second derivative of g were both equal to 0. Now we need to pick our test points. So I might pick 0, 3, and I don't know, 6. Right? Then we are looking at g double prime was equal to negative 12 times x minus 2 times x minus 4. So note that first factor is always going to be negative. This one will switch at 2. And this one will switch at 4. So for x equals 0, g double prime of 0, the first factor is negative. The second factor, if we pick something less than 2 and subtract 2, will wind up negative, or 0 minus 2, you get a negative. And then 0 minus 4 is also negative. And so negative times negative times negative, odd number of negatives, we get a negative result. For 3, second derivative evaluated at 3. Again, that negative 12 is always going to contribute a negative piece to our factor. 3 minus 2 is now, whoops, sorry about that. 3 minus 2 is now positive. But that 3 minus 4, we're still at negative. And negative times negative, we have an even number of negatives. So we get a positive output. And then at x equals 6, that second derivative evaluated at 6, that negative 12 is still negative. And then 6 minus 2 is positive, as is 6 minus 4. We have an odd number of negatives, we get a negative. So we have negative, positive, negative. Now, if we see what this means in terms of G, negative is bad, we're frowning. Positive is good, we're smiling. Negative is bad, we're frowning. So what we wind up with then is that we are concave down. So G is concave down on the interval from negative infinity to 2, and then again from 4 to infinity. And G is concave up on the interval from 2 to 4. So in terms of just briefly visualizing what this would look like, oops, give myself enough space. If we want to just briefly visualize what this means in terms of the graph, we start off concave down at 2. So we're going to go from a cap to a cup to a cap. So this is just a rough sketch of what the function might look like. All right.